Okay, today we're going to be talking about functions, equations, and systems of equations. Our three topics we're going to start off today is creating equations, reasoning with equations and inequalities, and building functions. Here is the vocabulary for this lesson. We have constraint, parabola, function notation, maximum, minimum, quadratic function, linear programming, objective function, and solution. My I can statement for AREI.11 is I can explain that a point of intersection on the graph of a system of equations y equals f of x and y equals g of x represents a solution to both equations. Alright, so we're going to start off with an example, and it's going to be 12x plus 20. So the first thing, you already start off by pressing your y equals key. To the right of the y1, you'll enter 12x plus 20. And then you press the Windows key because it set up the borders of a particular graph. A good function for the window key is negative 10, 10, 1, negative 10, 10, 1, and 1. If that is exactly correct, all you have to do for the last step is press the graph key and your function rule will be shown. Alright, let's do another example. We are going to do 15x plus 25. Again, you would always press your y equals key to clear it out. And then you'll enter the 15x plus 25. And you'll press your Windows key to make sure every one matches with it. Negative 10, 10, 1, negative 10, 10, 1, and 1. And if that is a really good function, then all you do is press graph. And your graph rule is shown. Alright. For our next example, my I can statement is f.if.9. I can compare properties of two values algebraically, graphically, and numerically extend to quadratic, simple power, and inverse variation function. Okay, so we're going to do a vertex formula. So reminder, the vertex formula is x minus h with the parentheses squared plus k is equal to 0. So the first step is you have to set it to equal to 0. So for our example, we are going to use y equals x squared minus 2x plus 5. And we need to find the minimum of it. First, you will set up the equation equal to 0, which is x squared minus 2x plus 5 is equal to 0. And then you will minus 5 for both sides. You will cross that out, that equals to negative 5. Alright, so after we have minus 5 for both sides, we are left with x squared minus 2x will be equal to negative 5. So then after that, you have to find what half of 2 is, which is negative 2 is, which is negative 1. So it will be x, to put it back in the vertex formula, it will be x minus 1 squared, since you're minusing 1 and you're minusing 1 on this side, it will be x minus 1 squared equals negative 6. Alright, here's another problem that we're going to do, which is y equals x squared plus 2x plus 6. So you know, first you have to put in the vertex formula. So x squared plus 2x plus 6 is equal to 0. You minus 6 for both sides. You cross that out. X squared plus 2x is equal to negative 6. So again, you have to find what half of what b is. So half of 2 is 1. So the final answer for the vertex formula, you have to add 1 to both sides. And the final answer will be x plus 1 squared equals negative 5. And that's how you do for a vertex formula.
Our essential question is, how can algebra describe the relationship between sets of numbers? The I can statement for I.CED.4 is I can rearrange formulas for a wanted variable. For this first example, we are going to do S equals UV plus W. We are solving for V. First, we have to subtract W. That gives us S minus W equals UV. Because we are solving for V, we need to get it by itself. So we divide UV by U. Same to the other side. So our answer is S minus W divided by U equals V. For another example, we have L equals MNO and solving for O. To do this, we just have to divide by MN to get O by itself. We do this to both sides, and that gives us our answer, L divided by MN equals O. For our next standard, F.IF.S is I can use a graph to determine the domain. To do this, we just need to find where X lies on the X-axis. We do this so X is greater than or equal to 1, but it's also less than or equal to 7. So the domain for this graph is 1 is less than or equal to X, and X is less than or equal to 7. For the next example, we have that 10 is less than or equal to X, while X is less than or equal to 20. So our domain for this graph is 10 is less than or equal to X, and X is less than or equal to 20. For one of our last standards, we have F.BF.1. The I can statement is I can create a function from two quantities. Our question is, Annie is buying apples for her picnic. 1 pound of apples is about 4 apples. Each pound costs $2.25. How much is the cost if Annie buys 16 apples? How much if 20 apples? So our function is $2.25 times X equals Y. X is the pounds and Y is cost of apples. So first we have to find how many pounds is in 16 apples and how many pounds is in 20 apples. So if each pound cost is 4 apples, we'll divide 16 by 4 and 20 by 4. This equals 4 pounds and 5 pounds. We then just have to plug in our pounds into our equation. It's $2.25 times 4 pounds equals $9, and $2.25 times 5 pounds equals $11.25.
Your first I can statement for A.CED.3 is I can graph and interpret solutions of linear programming word problems. Your first question is, a fashion model has 50 units of silk and 68 units of cotton. She plans to use as many dresses of fabric A and fabric B. Each dress of fabric A requires 10 units of silk and 5 units of cotton. Each dress of fabric B requires 1 unit of silk and 8 units of cotton. Find the maximum of each dress made. So first you need to find your variables. X is equal to the number of fabric A, and Y is equal to the number of fabric B. G is equal to the max. Objective function is D equals X plus Y. Then you need to make a chart. Fabric A and fabric B go on the side. And then at the top, silk and cotton go at the top. Fabric A requires 10 silk and 5 cotton. And then fabric B requires 1 silk and 8 cotton. So the total silk fabric is equal to 50. And the total cotton fabric is equal to 68. Then you do X is greater than or equal to 0. Y is greater than or equal to 0. 10X plus 5Y is less than or equal to 50. Then you do 8 plus 8Y is less than or equal to 68. Then you have to get Y by itself. So 10X plus 5Y less than is 50. You subtract 10X from both sides. You have 5Y is less than or equal to 50 minus 10X. Then you divide everything by 5. So equals Y is less than or equal to negative 2X plus 10. Then you need to do x plus 8y is less than or equal to 68. Then you subtract x from both sides. 8y is less than or equal to 68 minus x. Then you divide everything by 8. Y is less than or equal to 8.5 minus 1 over 8x. Then you need to graph. The first one, your equation would be 10. So you need to start with 10. Then you go up 2 and over 1. Then you make the line. Your next one, you start at 8.5. You go down 1 and over 8. Then you would shade above because it's greater than or equal to. Your next I can statement is A.REI.10, which says I can verify that any point on the graph will result in a true equation with their coordinates are substituted into the equation, linear and exponential. Your first problem is 5, a solution to y equals 6x. So you write the equation, then you substitute it in. 5 is y, and the other 5 is x. This side is equal to 30. So is 5 equal to 30? No, it's not. So no, it is not a solution. Let's try another one. Is 7 a solution to y equals x minus 3? So again, write the equation over, then substitute it in. 7 is y, and 10 is x. So 10 minus 3 is 7. So yes, 7 is equal to 7.
I can identify the effect on the graph of replacing f of x by f of x and k of x for specific values of k. I can also find the value of k that is given in graphs. But the first problem, I have already put in the calculator for you. You do is press graph. Then you should get the answer to the 3 functions. For the second problem, I'm going to put in x to the 3rd. Then you should get the graph for the function. I can use function notation. I can evaluate functions for inputs in their domains. Extend functions to include quadratic simple power and inverse variation functions. Ashley reads 60 words per minute. How many words can she read in 10 minutes? This is your equation. Substitute 10 minutes for x because x equals minutes. Then you multiply 60 times 10, and that will get you to 600. So 60 times 10 equals 600. So Ashley can read 600 words in 10 minutes.